Assalamualaikum dan salam sejahtera semua. Ini adalah video untuk chapter 11, Deformation of Solid, Part 1. 11.1 Stress and Strain. Although solid may be thought as having a definite shape and volume, it's possible to change its shape and volume by applying external forces. A sufficiently large force will permanently deform or break an object, but otherwise, when the external forces are removed, the object tends to return to its original shape and size. This is called elastic behavior. The elastic properties of solids are discussed in terms of stress and strain. Consider a long bar of cross-sectional area A and length L0 clamped at one end. When an external force F is applied along the bar perpendicular to the cross-section, the bar extends by the amount of E, which is the elongation, as shown in figure on the next page. This is the figure of a long bar clamped at one end, is stretched by the amount of E under the action of a force F. As you can see here, the cross-sectional area of this bar is A, and there is a force pull this bar that makes the bar extend with elongation E. Now let us discuss about stress and strain. Definition for stress is the ratio of the magnitude of external force F to cross-sectional area A, where the force factor is perpendicular to the cross-section. Equation for stress is stress equals F over A, where F is the force perpendicular to the cross-section in unit Newton and A cross-sectional area in unit meter squared. So unit for stress is kilogram per meter per second squared or Newton per meter squared or Pascal. Stress is a scalar quantity. Stress is a quantity that is proportional to the force causing a deformation. How about strain? Definition for strain is the ratio of the change in length, elongation E, to original length L0. The equation for strain is strain equals E over L0, where E is elongation, L0 is original length. Unit for elongation and L0 should be the same. If unit for elongation in meter, so unit for original length L0 should be in meter as well. Strain has no unit. It is dimensionless. Okay? And then it is a scalar quantity. The result of a stress is strain. Strain is a measure of the degree of deformation. Now let us discuss about graph of stress against strain. So we have point A, B, C, D, and E. And this is dotted line of point T to C. Okay, so from point A to O or O to A, it is elastic deformation, and then point C to point E is plastic deformation. A is proportionality limit, B elastic limit, C is yield point, D is breaking stress point, and E is fracture or breaking point. So A is the proportionality limit. Okay, this is point A. Point A is the proportionality limit. The straight line graph O to A obey Hooke's law, which state below the proportionality limit, the restoring force F is directly proportional to the extension E. When the force is removed, the wire returns to its original length. This is called elastic behavior. B. This is point B. Point B is the elastic limit of the material. When the force is removed, the wire returns to its original length, still in elastic behavior, before point B. Beyond this point, the material is permanently stretched and will never regain its original shape and length. If the force is removed, the material has a permanent extension of OT. Okay, this is the line of OT. Okay, permanent extension of OT. The area between the two parallel lines, which is AO and CT, represent the work done to produce the permanent extension OT. OB is known as elastic deformation. O to B is known as elastic deformation. And then C. Point C is here. Okay. Point C is the yield point. It is the point where the plastic deformation starts. The internal structure of the material starts to change because of the plane or layer of the atoms slide across each other. Okay, this is the illustration of internal structure of material slide. Okay, layer of the atom slide across each other. When the force increases, the extension increases rapidly. D, this is point D. Point D is breaking stress point. Beyond this point, the material thins and necks are formed. Like this. Okay? Like this. After point D, the material thins and necks are formed. Okay? E. This is point E. Point E is the fracture or breaking point. It is the point where the material breaks or fractures. Now, let us compare about elastic deformation and plastic deformation. For elastic deformation, extension does not exceed the elastic limit of the material. But for plastic deformation, extension exceeds the elastic limit of the material. For elastic deformation, when stretching force is removed, the wire returns to its original length. But for plastic deformation, when stretching force is removed, the wire does not return to its original length. The wire is permanently lengthened. For elastic deformation, it obeys Hooke's law. But for plastic deformation, it does not obey Hooke's law. For elastic deformation, it does not change the internal structure of a wire. But for plastic deformation, it changes the internal structure of a wire. For elastic deformation, when Hooke's law is obeyed, the energy stored during elastic deformation is fully recovered when the force is removed. For plastic deformation, during plastic deformation, energy is converted into heat. Now let us discuss about graph of force against elongation for brittle and ductile material. Ductile materials is material undergoes both elastic and plastic deformation. Example of material that is ductile are steel, copper, and aluminium. Brittle materials are materials that show elastic deformation. Example for brittle material are glass and bone. We will continue in part 2. Thank you, class.